Hello and welcome back to episode 4 or part 4 of the Q Learning tutorial series. Cool, yeah. So let's get into this. Last time, if you remember, we actually worked on, and by the way, if you haven't checked out parts 1 through 3, definitely check those out because you will probably be a little lost if you have not. But last time we worked on formatting our observations, and then we made this lovely experience replay right here. So today what we're going to do is first we're going to add in this little function that I forgot to add in last time called pre-process observation. And all this does is it essentially takes our filter obs function, and then our get stacked obs, and it just puts both of those together so we don't have to call one after the other constantly. We can just call pre-process observation, and that will do both of those for us. The next thing we're going to do is we're going to work on the training loop. Now, I know last time I said hopefully we would get the training loop done and the training function, but looking at it, I think it's a bit of a stretch. We're going to go for the training loop. We'll see how far we get. The training function itself is very important, and I want to go really in depth on that. And I don't want to, I want to go in depth as possible. And I don't want to leave anything out, and that is why I'm waiting to possibly do that. But anyway, let's get into the training function, or not the training function, the training loop. So this is the loop we had originally made, and I think the second part of the series. It's a little outdated now, so we are going to amp this up. The first thing we're going to want to do is get rid of that and define some constants. So there's a few things we're going to want to do. Let's see. So in episodes, this is going to be how many total games we play out. I have 100,000 here. In reality, that's not really going to happen. Let's take that down to 10,000 for now. Even that's probably not going to happen. But the max steps, we have that here, right? So we're just going to get rid of that here. This is the max number of steps in a single game. ER capacity, this is how many possible things we want to put in our experience replay. I think for my computer, I can do about up to 150,000 without running out of RAM. I have 64 gigabytes of RAM though, which most people probably do not. So we're probably going to want this at 50,000 at the greatest, maybe. They use 1 million in the paper. We don't have that kind of compute and storage on our hands though, so we can't really do that. The next thing we're going to want is the number of actions. So right, there's 4 actions: the no-op, start game, right and left. After that, we want the sort of the frequency of which we'll be doing things. So the first is the update frequency. So how commonly we will be updating our network. We don't actually need that for now, so I'm going to comment it out for now. But then also the frame skip. So the frame skip is this idea that you don't necessarily need to look at every frame in the game, or at least choose what action to take. What you can do is maybe, in our case, we'll be skipping 3 frames. I believe it was 4 in the original paper. We can actually look at a frame and then take that same action for 3 or 4 frames. And then we actually are 3 to 4 times roughly as efficient in terms of playing out more games without actually having to do the additional processing or computation. Just because a frame is such a short time frame, we don't need to be looking at that short of a time frame. We can expand it a little. Next thing we want is a print frequency. So we'll obviously be printing out updates as this trains, and we'll do that maybe every 100 games or so. Let's reduce this for 10 because I want to show you guys this a little faster. 100 takes a little bit long to run. The next thing we want is an epsilon. So if you remember, a policy, this is very important. A policy is how we decide what actions to take. I'm actually going to zoom this in a little. I just recently realized this might be a little small, so hopefully this is a little bit better. But a policy is how is that better? Tell me in the comments if this is too small and I can zoom in more next time. But a policy is how we decide what actions to take. And it's often denoted by pi. I don't know how to do it, but pi, the Greek, is it Greek? I think, letter. And it's essentially given a state. So you would say policy or pi, I'll just do p of s is some state. It should ideally give us either an action or a distribution over actions, the probability that we'll take each action. So what we want to do is ideally, our policy should basically, because we'll be generating Q values for each action, right? So say we're in a state and we have 4 possible actions. Maybe the first value, the Q value of the first one is 0.1, then 0. We'll just say 0, then 0.5, and 0.4. Well, in this case, generally we want to take, how do I get rid of that? There we go. Oh, whatever. Generally, we want to take the thing that has the highest Q value because that typically means we'll get the best reward if we follow that path. I made these add up to 1. They don't have to, though. This could be like 50. And then we'll definitely want to take this one, right? Because this would say this, taking this state has the highest chance of leading us to the best returns. Or it expects returns of 50. As opposed to here, it'd be like 0 and here, 0.4. But if we always just take the best sort of what we think the best course of action is without exploring anything, this estimate might be wrong, right? This might be 0.1, but it might be 0.1 because we've only taken one sort of game that played out that path. And that time we happen to get 0.1, but maybe if we were to play out a lot more, we'd find out that that was just really unlucky and this should actually be closer to 100 in reality. So we don't always want to take just the one with the highest Q value. Sometimes we might want to take a random policy, and that's what we'll be doing. This is called an epsilon greedy policy. And essentially, it's very simple. We generate some random number. So if a random number is less than epsilon, and epsilon is some value we'll define, it's the chance of taking a random action, then we'll do a random action. Otherwise, take the action with the highest Q value. So this is kind of the policy we'll be using. It's E-greedy policy or epsilon greedy policies are pretty common. So the reason I mention that is because we will want to have what's called a number of annealing steps. So our epsilon will actually start out at 1. So we'll be taking completely random actions while we kind of build up our data storage. And over the course of this many episodes, in the original paper they use a million, or not episodes, but steps, we will anneal that down to a value of 0.1. So 10% of the time we will be taking random actions. So this is just a little function I made, just a little lambda. So if we just do like epsilon, maybe we're on step 100, except for epsilon, this would be our chance of taking a random action. While if we're on a very late state, again, we eventually get down to 0.1, just a linear decrease. Here I'm using 1E5. I'm going to change that to 4 for now, just so when we do the training, it will be easier to see this faster. So it should be like by 100 we have that, by 1,000 we have that, and by 10,000 we're finally down to 0.1. Cool. Now we can actually work on the actual loop itself. So that is cool. So let's see, what do we want to do here? The first thing we want to do is make our ER, our experience replay with our ER capacity that we defined here, 50,000. Next, we want to make a model. Now our model is just our DQN, right, with the number of actions here. We actually define this here. I don't know why. Let's just put this here. Again, I'm using the GPU, so I put .CUDA. If you're using a CPU, you can probably just leave this alone or put .CPU. I think it's CPU by default though. And then we'll want to keep track of several things, 2 of those being the total rewards we get, so we can sort of see how we're doing over time. And we might graph this at the end or something. And then the global step, so we know how many actual steps we've taken. Again, just sort of another to help us like look at metrics and stuff. So for step, so now we're actually gonna have multiple episodes, right? Multiple games. So before that, we're gonna say for episode and range of in episodes. So this will be for each game, essentially. We will first make new previous frames, right? After each episode, we want to start fresh on what our previous frames are. And here we can actually use our preprocess observation function to start to get our new observation, our first observation of the episode, right? So m.reset resets our environment, returns us an observation. We then pass that into our preprocess observation. We get a new observation, our preprocessed one, and our new previous frames. Cool, so that's how we started out. Throughout the single episode, the 2 things we want to keep track of are the episode rewards, the reward we get per episode. and what step we're on. Again, these are partially just for keeping track of metrics. Yeah, said that right. So the next thing we want to do is we go into this for loop, and the first thing we want to do is, as we were doing before, choose our action. And remember here, I mentioned we were going to come back to this whole Q values thing, and indeed we are. So we are going to take all this out, and we are going to change this such that first we want to check if, let's make this nice too. First we want to check if this random number is going to be less than epsilon of our global step, right? So our global step, what step we're on, this will get the epsilon of the current step, and we'll check if we want to take, this will essentially decide if we want to take a random action or not. And if we do, we will choose a random action between 0 and 3, and that will be our action. However, if that does not happen, what do we do? And in this case, we want to, my throat's starting to hurt. So first we want to get our observation, convert it to a tensor, send it to our GPU if you're using a GPU, and then we want to throw that into our model to get our Q values. Cool, so we got our Q values. What do we do now? Remember, all we have to do is, well, first we have to detach them and get them on the CPU, and then from there, we can do an argmax to figure out which action has the highest Q value. So we've chosen our action. What do we want to do next? And now we want to actually take the action, right? Just as we're doing here. Except for now, this is going to be a little bit different. And I'll come back to delete this later. It's going to be a little bit different because we're using this frame skip. We're actually going to want to have a for loop that does this. Let's do this. So we're going to track the cumulative, the cumulative reward in this for loop. And we're going to go for, in our case, 3 frames. And for those 3 frames, we're going to enact the same action every time, get back an observation, a reward, and whether or not this is a terminal state. So we add our reward we get to our cumulative reward, and then we do a quick check to see if we are done with this or our step is greater than or equal to max steps we want to break. Now, because we're doing this way, we do actually have to change one more thing instead of using a for loop here. It's probably going to be a little bit easier to use a while loop. So I'm just going to say while step is less than max steps. And we also will want to increment this at the end down here. So we're just going to add 1 to the step each time and also add 1 to the global step. And this is just because, right, we want this step to increment 3 times once we finish this loop because we'll be taking 3 different actions. So now that we have that, we should actually be taking our actions. So what we want to do next is sort of make sure our reward is looking correct. So the episode reward, we will add the cumulative reward to it. And then our reward we use for actual training and stuff, we will use our format reward function to adjust that properly. The reason we don't use it here is because we are purely going to be using this episode reward to keep track of how our agent is going. It's like a metric. And we want to see the actual reward we're getting as opposed to this sort of normalized value. I guess you could use the normalized value. There's no problem with that. But I don't know, it's just not how I'm doing it. So this should work for us. So once we have that, we want to remember we still need to put this data into our experience replay. And even before that, we need to pre-process our new observation, right? So our next obs, this new obs we got. I feel like obs is just a really weird thing to say, but anyway. So we pre-process our observation, our new one, and now we can add this new observation to our experience replay. So we have the old observation, our action that we took, the reward we got, the observation that led us to, and also a 1 if this is a terminal state, a 0 if it is not. Again, this will come into play once we get down to the actual training method. And the last thing we want to do is we want to set our current observation equal to our next observation as we advance into the next step of this. So I will leave the rendering here for a second so we can check this out, but I am going to comment this out soon because we probably won't need it. Maybe we should actually just play this right now. Oh, one thing before that. I almost forgot, we want to append our reward. So at the end of each episode, we've accumulated this episode reward, right? Well, let's append that to all rewards so we can track how we're doing. Now, we've written quite a lot, so I kind of want to run this and see how, make sure it's working. I don't know why it's still there. Let's run this and see what happens. Nice. Pre-process obs is not defined. That is. Let's figure out to run this. Now let's try that. Oh, there it works. Okay, so this is really fast. It hit one. So you can see now we're actually playing through multiple episodes, except for we got an error. What's going on here? Yes. So the reason it was so fast is because, remember, we start out with an epsilon of 1, which means instead of running anything through our neural network, we'll always just be choosing random actions. And what happened here is when we ran into the first case where we actually use our neural network, it was like, hey, we were expecting this input, but we actually just got, it was expecting one channel because if you remember, we said that we're taking an input of one. Where is it? Here we are. We're taking an input of, I said we were taking an input of 3. That's not right either, right? We should be taking an input of 4 because we have 4 frames stacked. So let's move this in frames up here. We might as well just move this whole thing up here. And now that, and we can put in frames here. Hopefully this should do us justice now. So if we remake all of this, we can get rid of that. We can get rid of that. Hopefully we don't get any errors here, but we will see. So no errors so far. Oh, it's actually doing pretty well for like completely random. I guess maybe that's kind of normal. Oh, we did get another error. Okay, I don't want to keep you guys waiting, so give me 1 second while I figure this out and I'll be right back. Okay, I am back and, pretty stupid mistake. I forgot to comment this out earlier. I had a feeling I would do that. And we actually weren't, this observation, right, happened to be, we needed pre-processed observation. This one was not pre-processed. This shouldn't have been here. Bye-bye. Problems go away, and there we go. Let's see, and it is playing. So we shouldn't get any errors. Let's wait and just kind of watch it for a little bit to make sure, because it might just be taking random action still. It's not, I did check, but. So cool. Everything's working. But as you might have noticed, nothing is improving, which is a pretty big issue, and the whole goal is to be able to actually play this game and not just play it randomly. We actually want to do well. Who would have guessed? So what we actually need to do is we need to train our agent. There is one more thing I want to include actually, and that is we want to start printing stuff out. So so we have the print frequency is 10. So let's actually use that and let's print out sort of some statistics to see how we are doing. And this should work in place of, let's see, so we have an if statement. Once we hit the print frequency, we're essentially going to print out the episode, the step, the epsilon, and the average reward over the past, in our case, 10 episodes. The reason we do this is, I think it's pretty obvious, so we know how soon, so we can actually get rid of this render now, because the rendering actually makes this go a lot slower. And ideally, we can kind of see how we're doing, because it will be printed out here. And I can leave this going for a long time, and we're not going to see any improvement because we're not actually changing our model yet. It's still just going to keep taking random steps. I say that it looks like it's improving for a second, but obviously not. So that is what we are going to tackle next episode. I am going to save it for our next episode because it looks like we are already coming up onto a pretty long episode. I think they actually all are pretty long. I probably need to talk slower sometimes, but oh well. So just quick summary of what we did, right? First we added this thing that I forgot to add last time just for the pre-processing of observations. We added some constants, and then we put in our training loop that essentially loops through the game several times, and in each step we first test if a random number is less than our epsilon, that is starts off very high but it ends up at 0.1. So essentially we'll be taking a lot of random actions at the start and then less as we go on and on, all the way down to only 10% of our actions being random. We do that so we can explore new states and make sure we're not missing out on anything good. We don't want to just focus in on something without exploring and knowing what the other possibilities are. Otherwise, we do use our model, which at the time is random, but won't be once we start training it. And then essentially we use that action in several frames. Once we do it, we update our rewards, we pre-process the new observation, and we add the experience to our experience replay. And then we essentially print out these updates as we go. And here we have an agent that is playing, albeit not doing very well. And next episode, definitely stay in tune because we will finally be getting this lovely training function done. We're going to do a deep dive onto why it works and how it works. That is, again, why I'm saving it for next episode. I really want to put a lot into that just to make sure that I explain this as clearly as possible and get the point across as to why Q-learning, why deep Q-learning actually works, how it works, why we use the loss function we use. So definitely stay tuned. Definitely, if you found this video helpful, like and subscribe. It really helps the channel and I really appreciate it. Thank you so much for watching and have a great rest of your day.